Since there are so many elements, there needs to be a system to organize them. This is where a Russian chemist, Dmitry Mendeleev, gets in. In the late 1800s, when only about 60 elements had been discovered, Mendeleev decided to arrange the elements in order of increasing atomic weight. Therefore, while doing this, he also organized them so elements with similar characteristics were grouped together. While he was doing this, it was necessary to leave some blank areas in his organization for elements that have not been discovered. After Dmitry Mendeleev came Henry Moseley, who in 1913, through his work with X-rays and the discovery of the atomic nuclear charge of the elements, which we now call atomic numbers, he rearranged the elements in order of increasing atomic number. He is credited with the discovery of the modern table, as the modern table is organized in the order of increasing atomic number. This brings us to the periodic law. The periodic law is when elements are arranged in order of increasing atomic number. There is a periodic pattern in their physical and chemical properties. A period on the periodic table is just a horizontal row. The current periodic table has 7 periods, with an island of 2 periods down below. A common question is why the 2 island periods are present. In reality, it is because if those 2 rows were put into the periodic table where they belong, the table would take up so much space and would not easily be able to fit in one piece of paper. The vertical columns on the periodic table are called groups or families. Groups are very useful when predicting the properties of an element. The groups are numbered from 1 to 18 from left to right, and some of the groups have special names. Here is an image with the groups along with their names. Metals are found on the left side of the staircase, and they all have very similar properties. They are shiny, good conductors of both heat and electricity, malleable, and ductile. Malleability and ductility refer to the substance's ability to be deformed without cracking. Elements to the right of the staircase are called nonmetals. They are brittle in their solid form, dull, poor conductors of heat and electricity, and have much lower melting and boiling points than metals. This is why many nonmetals are gases at room temperature. Some elements do not fall under metals or nonmetals. These are called metalloids. These are on the staircase line. Elements that are most commonly referred to as metalloids are boron, silicon, germanium, arsenic, and antimony, and tellurium. A very important feature of an atom that helps predict its chemical properties is the quantity, and the location of electrons. More specifically, valence electrons. The valence electrons are the ones that participate in the chemical reactions changing the properties of an atom or molecule. The column an element is in on the periodic table will indicate how many valence electrons there are present. In chemical bonding, atoms will give, share, or take electrons to have a full outer energy level. For all elements except hydrogen and helium, a full outer energy level will have 8 electrons. Hydrogen and helium will have 2 valence electrons. This is called the octet rule. The first trend is atomic radius. Atomic radius is defined as 1/2 the distance between the nuclei of identical atoms that are bonded together. As you move down the periodic table, the atomic radius will increase because new energy levels are needed to hold electrons. The next trend is ionization energy. This is defined as the amount of energy required to remove an electron from an atom. As you move from top to bottom in the same group, the ionization energy will decrease. This means it will become easier to remove an atom's outer electron. As you move from left to right in the same period, the ionization energy will increase. The next trend is electronegativity. This is defined as the ability for an atom has to attract other electrons. As you move down a group on the periodic table, the electronegativity of an atom will decrease because the increased amount of energy levels puts the outer electrons very far away from the pole of the nucleus. Electronegativity increases as you move from left to right across a period because there are more positive photons in the nucleus, which creates a stronger pull on the negative electrons in the outer shell. A major exception to this trend are noble gases. The final trend is reactivity of metals and nonmetals. The farther down a group of metal is, the more reactive it is. This is because it is easier to lose electrons. The farther up the group, the more reactive the nonmetal is. This is because it is easier to gain electrons.